Hey everybody, how about another daily space weather show? We've got some pretty fresh imagery once again. As you may have come to expect from the Smash News Network, least busted name in news. That is our most active sunspot, one that's not even in view yet. There was a massive CME from that area as well as another earthly directed one. We'll get to it. There's a little zoom out to help show the scale of that series of plasma filaments there. That is 171 angstroms, part of the extreme ultraviolet spectrum from Solar Dynamics Observatory, depicting the extreme ultraviolet emissions of iron 9. Some more totally sweet views for you here. And we've had a small solar uptick since yesterday. Now, in the lower center of your screen, south of massive sunspot 3576, there was a filament eruption, and it contains earthly directed components. Most will miss Earth to the south. Some will strike Earth on the 13th. Sometime like late in the day on the 13th, we think, and I tend to agree with the forecasts by both NOAA and NASA. And there's the full disk view. Now let's briefly take a moment to see what's going on as far as volcanoes go. And we've got the Reykjanes, the Grindavik eruption, has ceased. So that's always good news if you don't want to be evacuated from your home. Ibu hasn't ceased. It's continuing to explode. Also, Semeru, Merapi, Dacono, Popocatépetl, Santiaguido, Fuego, and Sabancaya producing a 25,000-foot plume of volcanic ash. Please do not pole vault the caldera. Do the math. But don't pole vault the caldera. It could be unhealthful. Next, earthquakes, and earthquake watch for the western portion of the North American plate boundary there, the Pacific Oceans, the Pacific/North American plate boundary there. A whole series of quakes. Are any of them foreshocks? Well, that's an awful lot of quakes. We've had an uptick in the past few weeks in that area. Here's what's been shaken for the past 24. Philippines had a 5.8. I think that's the largest quake of the past 24. That was at 3:22 Universal Time this morning. So 5.8 at the Philippines. And then how about a 5.4 magnitude aftershock? And that's it for 5 and greater magnitude quakes. And let's get back to some more space. Oh, check it out. We've got some more sweet imagery for you here, folks. Geez, not half bad. Not half bad at all. So here's the southern hemisphere, and if you look to the southern portion of that sunspot 3576, right in the center of your screen there is a filament eruption. That was a massive coronal mass ejection right there, blasting off, and part of it is headed right toward your doorstep. Let's move to the north. There's the equatorial view, and we've got a number of massive filaments remaining. Look at this filament right down here. It's absolutely gigantic. Also up here, another huge, very dense filament. Up here, another huge, very dense filament. Another massive filament right over here. So, massive filaments all around sunspot 3576. The likelihood of coronal mass ejections in the next 24 hours, nearly 100%. We also have a proton event going on, as if there's not enough space weather happening. So the real news isn't in the solar wind. It's in practically everything else. There you can see a huge prominence up by the North Polar region as well. A great Earth scale there showing you that it's a few 100,000 kilometers in size. part of it probably encircling the far side of that polar region. You can sort of see likelihood of connection there. A big old crown prominence. Next, we'll get to some stats. The 10.7 centimeter radial flux now up to 194 solar flux units. 194 for the radial flux. There is the 1 year graph to contextualize. The red line is the sunspot number. The black line is the radial flux. And if somebody's telling you the sun is shutting down, they're either lying or they're unable to understand what a basic number means. I mean, there are people still chanting this. We call them cultists. And the crazy part is that there are more cultists on this planet right now than I think have ever been on the planet before. It's pretty berserk. The 3 features of a cult are: it has to be harmful, it has to have a living leader, and they have to believe nonsense. Those are the main features of a cult. And I'm at a loss. So Space Weather Enthusiast dashboard here does not include the forecast for the 13th. However, NOAA is forecasting a geomagnetic storm for the 13th. February 13th, geomagnetic storm conditions coming from a CME from today. So there you can see it's actually early in the day on the 13th. I'm sorry, I thought it was late in the day. Early in the day on the 13th, CME impact. And we've got a co-interacting region there. So the second CME that they're modeling there is faster than the first one, and NOAA is forecasting those to interact. That's known as a CIR, a co-interacting region, where one coronal mass ejection catches up to the other one, and that can have various different types of effects. They can effectively cancel each other out a bit, they can amplify each other a bit, or they could just arrive at the same time, sort of an additive effect, or they can arrive in succession. It's really unknown, as we don't have a whole lot of spacecraft out there to test it, to just be checking everything. Now, I'm not sure where Bepi Colombo and OSIRIS-REx and Parker Solar Probe and the ESA Solar Orbiter are located, but I'm not really going to worry about that too much. CME impact coming early in the day on the 13th February. Now, NASA somewhat agrees here. You can see there that one CME, the one that's missing mostly to the south, does have an earthly directed component. I would tend to agree with NASA. So that's NOAA's and NASA's forecast for CME impacts. Pretty similar there. Next Earth's magnetic moment from space for the past 4 hours. It's our geospace magnetosphere movie. So that depicts magnetohydrodynamic pressure. If you want to read about how the model is derived, head to the Geospace Magnetosphere movie page. Scroll to the bottom, click on the Details tab. There'll be a link there to the Space Weather Modeling Framework. You can even download the software used for it. Next, Earth's magnetic moment from the ground, and we have very geomagnetically calm conditions at the moment, so not a lot of fireworks happening. We have a slow solar wind here. It's a bit of a respite following a fairly lengthy coronal hole high-speed stream and some minor, little, tiny, barely noticeable coronal mass ejection impacts. So KP is at 1. KP1, the planetary K-index for you new viewers out there, press the subscribe button, is an average of global geomagnetism. An average of global geomagnetism. The planetary K-index is currently at 1. KP1. Next, solar wind, and the ACE is showing extremely diffuse solar wind and also kind of slow. The Discover, not nearly as diffuse, like over about 20 times as dense at the Discover, at about 6 protons per cubic centimeter, but only 345 kilometers per second, so quite slow. And you can see the plasma temperature down there. The bottom frame, which is the green line, is also declining. So the plasma is getting cooler, slower, and less dense over the past 24 hours. GOES magnetometers here are in a little bit of a lower highs and higher lows for the past couple of days. And if you're wondering where they're located, the GOES 16 and GOES 18, they are geosynchronous near equatorial satellites. They're orbiting at about 23,500 miles of altitude. Next, our top view ecliptic plane field plot. And what's going on in the heliosphere as far as magnetism? Earth is in a North Pole-oriented magnetic sector. And it looks like we can expect to be there for a few days yet. North Pole sector, shown there in green. Next, our line of sight field plot, depicting the polar fields in red and green for south and north respectively. The photosphere magnetism depicting North Pole in black, South Pole in black, and North Pole in white. Also the solar B field, depicted there in those blue potential field surface source lines. The B field is kind of like the net field, or you could say it's the field that goes through the magnet, this magnet being the sun. Next, coronal holes in our line of sight coronal hole plot. North Pole coronal holes here rotating in. They're not very well defined. Let's take a look at those from SDO. So there's SDO, 211 angstroms. And we may have some more well-defined coronal holes coming through here in a couple of days. At the moment, mainly just the one down there by the south heliographic polar region, which is interestingly of North Pole magnetic orientation, as you can see on that imagery. Next, moving to sunspots, and sunspot number here has now gone back up over 150. Again, we did have a little bit of a minor uptick since yesterday. Sunspot number here back to about 157, 158 maybe, something like that. And let's get to our flare probability monitor and scoreboard. But first, the synoptic map. So Spencer agrees with us that there are a lot of filaments around this area. You see that red that Spencer drew on there. I mean, there are a bunch of filaments here that aren't really covered, but there also are prominences that are covered. So prominence, prominence, crown prominence, prominences, prominences, prominences. Spencer missed some filaments, though, around here and up here. So, but I don't mind. Spencer does a fine job. Cheers to Spencer. Next, our flare probability monitor and solar flare scoreboard maps. And what the heck happened? They must be missing the SDO data there from the ISWA page. That's my story, and I'm sticking to it here at the Smash News Network. Least busted name in news. And press the like button already, for Gond's sake. Dear Gond, have you failed to press the like button? What the heck kind of a sociopath watches our video and doesn't press the like button? Are you a sociopath? Moving right along to sunspots from SDO. There's the equatorial view. And again, we do have a little bit of sunspot growth. So sunspot growth happening over here. Sunspot growth happening right here. Sunspot growth happening up here. Also a new sunspot rose down there in the southeast, right in this area. And there are more sunspots to rise behind there, undoubtedly, considering the flaring that we saw coming from behind that southeastern limb. What's that? You're looking for some extreme close-ups? Okay. There's sunspot 3576. That's not too shabby. Pretty decent. And let's take a look at the magnetic fields as it is still a beta gamma delta class sunspot group. So there is still quite a lot of magnetic shear there, although it has been degrading for days. So it looks like it grew a little bit right there at the end of that video. But yeah, mostly degrading over the past 3 days or so. However, there is still a lot of magnetic shear there. You notice you can see some solid black and some solid white right next to each other. So those are the areas that we call deltas. And those are the most likely areas to be associated with large solar flares. So let's talk about solar proton events. Now, these radio blackouts at the D layer of the ionosphere, they're caused by solar flares. Those equatorial radio blackouts and brownouts, those are solar flares. The direct radiation from the sun attenuating the D layer. In other words, removing portions of the D layer, ionizing it. At the same time, you've got these polar radio blackouts, especially at the south polar region, but also around noon local time there in the north polar region. You've got proton event-induced radio blackouts. Those are caused by the solar proton events as the protons are ionizing portions of the D layer, which is at about 80 kilometers of altitude. I don't know why I have that twice. So there's that ghost proton flux, and you can see we did see a spike in the greater than or equal to 100 mega electron volt, 50 mega electron volt, and 10 million volt fluxes. So the solar proton event continues, as do the radio blackouts. So that could last for a few days yet. Pretty hard to forecast when solar proton events are going to subside. And we did have a couple of M-class flares today on February 10th. Let's take a look at our favorite flare wavelengths. 131 plus 94 angstroms. And the most active sunspot is actually behind the limb. Here's a close-up of 3576. Sunspot 3576, one of the most interesting sunspots of solar cycle 25. There you can see that CME erupting there from that, right in that area right there. You see that flare blasting off. But like I said, the T-mass is a sunspot that's not yet in view. It's still behind the limb. And before we get to CMEs, let's take a brief look at a star chart. So there's what's going on overhead now over Lehigh Valley, Pennsylvania. You've got a tiny sliver of a moon up there. Actually, it's new moon. Yeah, it's new moon. So there might be a bit of a nothing of a moon. Anyway, it's setting anyway. It's about to set there just ahead of Saturn, if you catch a glimpse of the moon. And it's a little bit to the south of the ecliptic. Next, our solar system forecast. There are things today. Happy new moon to all my reverse werewolves out there. That's where things will be in a week on the 17th. And let's get to CMEs. But first, would you like to ask a particle physicist a question? Well, we can facilitate that. We'll tell you how in a minute, but make sure you subscribe to Eugene the Philosopher first. That's the most important thing. The way to send a question in, if you've got a question for a particle physicist, is at smashomash.com/forum. Just scroll down, you'll find the General Science Forum. Click on that, and you'll find the Ask a Particle Physicist segment section. That's the best place to ask a question. And we've got a playlist for it. Every week we put one in the Friday edition of the Space Weather video. And then the next week we release that video by itself, although the Gold Smash Team members get it right away. So right now, segment 12 is only available to Smash Team members, but you can always check out these great segments like Solar Protons, what do they do? Or segment 11, what is a solar energetic particle event? Perfect timing for that to become public, right? So perhaps check that out.
Is a proton going to do when it...
And there's a little teaser of what solar protons do. Next, our astronomy photo of the day. And it's apod.nasa.gov if you want to check it out yourself. Unfortunately, the Ginny, the Ingenuity drone, the Mars helicopter Ingenuity, damaged one of its rotor blades and has flown its last flight, unfortunately. So it lost contact while landing and fell a few feet, and that's suboptimal. So yeah, unfortunately, the Ingenuity rover has been retired as an active flying device. apod.nasa.gov, that's the rotor blade. And you can see the damage there on the end of it. And let's get to CMEs. CMEs, and man, oh man, we've got a lot of snow on the coronagraph. So look at all that speckling there. Those are all relativistic particles smashing into the SOHO spacecraft. Now, on these images, you'll see a coronal mass ejection off to your left, which would be the east. That's not earthly directed, but the second one out of the south has earthly directed components. It looks like NOAA thinks that both of those are going to have earthly directed components. I think only the southern one does, and I agree with NASA on this. Actually, NASA is forecasting less space weather than NOAA, so things have gotten reversed here a bit. NASA's usually a little more sensitive about it, as is our channel. So NOAA's forecasting both of those to have earthly directed components. Those are the co-interacting regions, while NOAA is forecasting both of those to have earthly directed components. NASA only the southern one, and we agree with NASA. So let's just skip that. Here is the C3 and C2. Let's get those a little closer to synced. So the left imagery is a little bit ahead of the right imagery. And we're gonna sync them all up properly here in a minute. That is actually our next segment. Let's just cut to our custom coronagraphs as we work our you-know-what's off to get you the freshest imagery when it comes to space weather. So there you go. Look at all the snow on the C2. Dag. That is a major series of relativistic particles. Also on the C3. So here's a little closer view. Yeah, so... And this is actually forecasted by NOAA to be a more serious event here. So could see a KP7 from this one. KP7 possible. So a major geomagnetic storm could be coming to a planet near you early in the day on February 13th. Here's an even closer view, and we've added the 193 angstroms to the SDO imagery in the center. Looks like quite a long duration CME there, as there's plasma still on its way out there several hours after the main coronal mass ejection. Here's an even closer view for you. So just south of sunspot 3576, some fireworks. Not half bad. And let's geez, what am I doing? What am I doing, folks? Oh, we'll also show stereo A. Let's show stereo A as well. Yes. Yes. So there's stereo A on the left. That's the raw coronagraph, and then the difference imagery on the right. Those are still yesterday. Now here comes today. Massive CME out of the east, and then another massive CME out of the south. Just splentacular. And let's get to filaments. So this is the ground-based solar observatory at Cerro Tololo, Chile. And look at the huge filaments. So we've got a massive prominence, a series of prominences around the eastern limb, crown prominence, series of prominences around the western limb. Those are the filaments that are hanging off the edge of the solar disk. And here's a better view of the ones that aren't. So, I'm just going to bring up the last image here once this plays through. So look at these filaments right here. I mean, this one right here is quite massive. I'm not sure if that's 1 or 2. Let's just call that 1. This one down here, that might only be 1 filament. Massive filaments there. Another one up here. Another big filament there. Filaments, filaments, filaments. Filaments, filaments, filaments. So quite a bit of activity. Once again, the likelihood of coronal mass ejections between today and tomorrow is just this side of 100%. So there are the past few hours from GOES 16 SUVI, which brings us to bonus features. Bonus features. They start out with, well, with that. Then they move on to that. Satellite charging hazards. And we don't have any. Next, the electron flux. It's still kind of low, as you can see there on the 1-year chart from Solon.info. Solon.info/solar contains a ton of information like that, the 1-year graph of the greater than 2 mega electron volt electron fluence. NOAA's forecasting an uptick, and I would tend to agree. It looks like it's already underway, so yeah, that looks good. I endorse that forecast. Cheers. Cheers to NOAA. That forecast looks legit to me. Next, the ionosphere, the layer where it's measured using radiography from those geosynchronous orbits I talked about earlier in the video. There's a great diagram of the atmospheric temperature inversions, the penetration of electromagnetic radiation, chemical concentrations, and here's the ionosphere. It's the F layer, which is located at about 300 kilometers of altitude. It's depicting vibrational frequency, and it's courtesy of the Australian Government Bureau of Meteorology. We haven't had a lot of space weather, so we're not having a lot of low-frequency anomalies there. That's no surprise. And everything looking quite nominal when it comes to the ionosphere. Here's the anomalygram, anomaly in megahertz from a 30-day median. We won't spend a lot of time on that because it's pretty unremarkable. Here is the whole atmosphere model. Total electron content on the left, maximum usable radio frequency on the right. The latest images of the closest star. And let's take a brief look at sunspot 3576 once again. Yeah, less deltas than yesterday. Still magnetically complex, but much less magnetically complex than 24 hours ago. Sunspot 3576 becoming less likely to produce an X-class flare. So there you go. Them's the facts. And the next order of business from the Smash News Network, least busted name in news, is meteorology. We show real data, and then what we do is we make comments on the actual data. I know, crazy, right? I don't rely on models. I rely on understanding how the physics works. How the physics work? Singular, plural, I don't care. But there is a low in the center of the, right near the, like Texas, right near Texas-Mexico border, and that is going to pick up some steam and drop some of the white stuff. So, there's a brief tidbit of what's to come. We've got some forecasts for you here in a moment. Let's take a look at the earthly winds. There are the surface winds of the east, followed by the jet streams. Jet streams of the central world, followed by the surface winds. Surface winds of the Americas, and the jet streams. Clouds and fog are next. Shortwave radiation map is what you're seeing. Satellite-based system depicting 3.9 micrometer infrared radiation. Here's a little closer view of another atmospheric river making its way from the Pacific. A bunch of Pacific Ocean moisture there, making its way across the U.S. Next, the coldest place in the world. Would you like to guess where it is? Where do you think the coldest place in the world is, folks? Let us know in the comments. We'll give you a minute. It's in Siberia, 54 degrees below zero Fahrenheit, negative 54 degrees Fahrenheit. In Siberia, them's the facts. There is the full temperature map. And it was like in the 50s today in Pennsylvania. A great day to ride your bike and keep the tires in contact with the road. Next, our weather.gov map, and you can see some winter weather warnings in a lot of places. It's got people going berserk on YouTube. And, yeah, weather.gov. Get your weather warnings if you like, or perhaps just view these forecasts. I don't know. Might be easier. There's some heavy snow about to start in Texas and then make its way across Oklahoma and to the northeast. So some heavy snow there. You can see that very, very dark blue system. Like I said, that low pressure is going to accelerate and annihilate. Anyway, here's our snow forecast. That's the next 72 hours, the GFS model. 72 hours of positive accumulated snow depth. Here's our total accumulated precipitation and some heavy, heavy moisture coming to the southeastern U.S. Some areas there about to get 5 inches of rain. 5 inches of rain in places like South Carolina and Georgia. 72-hour GFS total accumulated precipitation forecast in inches. Last but not least, the temperature anomaly forecast in degrees Celsius. 72-hour GFS model. And that's what's going on. Lightning is next. We do have a line of lightning here from Texas all the way up into West Virginia. Here's a real-time lightning map courtesy of lightningmaps.org. At the moment, terrestrial strikes, we do have some. In New Mexico, south of Tucumcari, there is thunder rolling in. Convince your friends and foes that you're Zeus by forecasting thunder at lightningmaps.org. We'll close out with Doppler. Here's a full 50-state view. Here's a lower 48 view. So Doppler radar, clouds and fog, satellite-based systems, once again 3.9 micrometer infrared radiation, and the water vapor map. As you can see, that Pacific Ocean moisture making its way across the U.S. It's time for a recap. Ground-based Doppler radar systems which depict vertical motion of water and ice crystals. Space-based systems that depict the infrared radiation of clouds and fog at 3.9 micrometers. Shortwave radiation. And a different frequency of infrared spectra, 6.61 micrometers. And also infrared depicts the water vapor. It shows the dry air, it shows the moist air, and it shows what's going on when your Doppler is unclear. Thanks for tuning into the Smash News Network, least busted name of news. I've been your host, Dan, a.k.a. Smash-O-Mash. Who comes up with the facts? This guy, that's who. Still controversial in 2024. Facts. So watch out, folks. Facts. Anyway, we out. In the meantime, may that solar wind be at your back.
What?